This is test ID 22, component ID 00. It's for the after-catalyst oxygen sensor, B2S2. It's the switching ratio test. Now the 00 component ID indicates we have a maximum limit. Now remember, occasionally you will see an FF. That means it's an incomplete test. This is for the left side sensor when dual O2 sensors are used as catalyst monitors. The PCM monitors the after-cat oxygen sensor voltage and compares the switching of fuel control sensors to after-cat fuel switching. Now the values aren't converted into measurement values, so use them as a relative indicator of operation. The typical data will be used to show you actual vehicle results. We didn't have a screen capture, so we had to show you what we had in data. Here's a vehicle we captured several months ago. The test value was 0. The maximum limit was 195. Remember, the monitor fails when the value is above the maximum limit. And again, we're going to use the lab scope to verify failure. This is an example here of the red trace of the after-catalyst signal. We're going to use scope patterns to help direct us to a problem area. We cannot always identify the cause of failure, so keep that in mind. This is the after-cat signal on a bad one. This example is a failure where the red trace is the after-cat signal and it shows far too much activity when compared to the front catalyst. It's almost a perfect switch. It's counting the switches. So we saw a spec that says 195 is the maximum count. We had 0. This count is going to be too high. We're going to look at live scope patterns and give you some more help in being able to identify and verify Mode 6 data. We're going to take a moment to talk about the pre-cat and after-cat oxygen sensor voltages. The red is the catalyst monitor. The green is the fuel control. Now we need good fuel control in order to judge the cat monitor, and we're going to talk about that. So let's stop this and examine exactly what we're looking at here. If you'll notice, the red trace is almost steady. Very good. The green trace is going from rich to lean. Now rich is the high voltage. The lean is the low voltage. We have good activity here. We must have near normal O2 sensor in the front before we judge the rear. Why? Let's do a snap accelerate and we'll show you why. We do a snap accelerate. Both sensors go full rich. The fuel control is full rich and the after-cat goes full rich. Almost at the same time. Notice we have some clipping. JTEC can go over 1 volt when the oxygen sensor is a little cool. Fuel control drops lean right here. We have a significant time delay before the after-cat drops lean. So we have quite a bit to see here. We want to watch the difference in fuel control and after-cat to see how active the cat is. We cannot stress too much that the cat must be fully warmed up before this test. Don't expect a cold cat to give you a good pattern. That's one of the fallacies. But also remember, don't overanalyze this. The PCM is going to detect the problem. Use this type of pattern to verify Mode 6 information. You don't have to figure it all by yourself. Mode 6 is already going to be telling you to look at this.